Oncology in the UK is facing big challenges with meeting targets for diagnosis and treatment. Every day a patient waits for a biopsy result is a day cancer has to grow. To save lives, we fundamentally need to be able to improve the cancer diagnostic process, and Isambard-AI is powering our work in this area. I'm Banerji, pathologist and interdisciplinary clinician scientist at King's College London. Our hospital trusts handle around 100,000 pathology cases every year, where paper-thin tissue slices are scanned in incredibly high resolution to spot anomalies and support diagnoses. With each case typically requiring 5 to 20 individual images of up to 150,000 by 150,000 pixels, some 4 gigabytes in size. The system faces a staggering wave of around 2 million massive files annually. A high-performance AI computer is essential just to ingest and process files of this scale in a reasonable time.
But speed alone isn't enough. Current pathology AI is a so-called black box, an opaque system that gives a percentage likelihood of cancer or a suggested prognosis with no insight in how it reached its conclusion and no space for debate. To tackle this problem, we've harnessed the incredible power of Isambard-AI to create a transparent computational pathology system that aligns AI and clinical reasoning. I'm Gregory Verghese, computational biologist and machine learning researcher, also at King's College London, and I've been working with Chris and a wider team on the computational side of the project.
We'll start with our input data, which will be our pathology.
For pathology imagery, our model training follows a unique dual-axis approach.
The first is a traditional bottom-up method, where the AI has shown images in which the visual markers of cancer are already obvious to the human eye.
The second is a top-down method, where the AI looks at multiple patients with similar medical characteristics, such as the type of cancer or resistance to a particular drug, and then studies their biopsy imagery to try and identify as yet unknown shared features.
This process finds new visual markers for cancer, which can provide new clinical insights.
The next stage is to add explainability, because although AI is incredibly good at finding patterns across massive images, it sometimes finds the wrong ones.
It might learn, for example, that slides from a specific specialist hospital are more likely to be cancerous, and so instead of looking at the cells, the AI starts focusing on that hospital's digital logo to make its prediction.
When pathologists examine a biopsy, they don't make decisions from the pixels alone. They first identify what type of cancer they are looking at and how advanced it is, and consider this in the context of the patient's characteristics and important molecular features of the tumour.
As you can see, we have quite a diffuse sort of infiltrative process here. This looks like a lobular carcinoma.
Our system is built to mirror this process by analysing the data with reference to the same medical concepts a human clinician would. Crucially, once the AI proposes a diagnosis, it has to present its case and reasoning to an actual clinician, who, if necessary, can correct any mistakes which the AI then uses to refine its final recommendation.
It's got a kind of similar grading assessment. We can relook at the slides and make sure whether we agree whether it's a grade 1 or a grade 2.
By aligning AI reasoning with clinical reasoning, we are transforming black box AI into a system that can explain, justify, and collaborate in decision-making. A true member of the multidisciplinary clinical team. Remote access to Isambard-AI was critical in our initial training phase, and will continue to be so as we scale to more data. Also important is the fact that as a sovereign AI resource, Isambard-AI allows us to create computational pathology models with secure NHS data right here in the UK, without the data ever leaving our shores.
The end result isn't just faster computing, it's a patient getting a targeted, personalised and justified treatment plan more quickly.
And with the confidence that their doctor has vetted and approved every step of the AI's logic.